Dear students, very good evening. This session is dedicated to discuss the important formulas that are used for designing the bolted joints. What are all the stresses that is induced in the bolted joints and the types of problem that could be expected in the end semester examination. Let us begin our discussion. So first is we have strength of screwed joints. First is tearing across the root across the root of screw threads. So tensile load is given by PT is equal to tensile stress sigma T into pi by 4 times of dc square, because the tearing happens at the weakest cross section. DC stands for core diameter, and DC is equal to 0.84 times of D, and D is called as nominal diameter. So nominal diameter is used for designating the screw size especially. Next criteria in the strength is direct shearing of bolt. Direct shearing of bolt is likely to happen in the region where the threads are not present or non-threaded portion. Let's say there is a plate over here, and let's say another plate. So in the non-threaded portion, due to relative motion of these two surfaces, the shearing action is going to happen. This could be specially observed in the flanges. So shearing load, that is P, is equal to tau, that is shearing stress, into cross section area. This happens at the shank diameter. This is called as shank portion, non-threaded portion. So at the non-threaded portion only, sliding of surfaces is going to happen, whereas in the threaded portion the sliding of surfaces does not happen. So diameter can be expressed in terms of load and shear strength, that is 4 into P divided by pi into tau raised to the power of 1 by 2. So this is the criteria, strength criteria. Next is induction of stresses in the bolts due to tightening. Initial stresses due to tightening. Very first one under that we have is tensile strength, tensile stress due to stretching of bolt. So here there is an empirical relationship between the load and diameter. So P is the load on the bolt and D is the nominal diameter. This is given by P is equal to 2840 times of D into N. This is the tightening load or load due to tightening of the bolt. And this is equated against P is equal to sigma T into failure area. Failure generally happens at the core part. That is 2840 times of D equal to sigma T into pi by 4 times of dc square it would be. And sigma T will be equal to 2840 times of D divided by pi by 4 times of dc square. And dc is once again equal to 0.84d. So we have seen the same formula earlier, but this is the new term that is being added. So whenever initial loading or induction of stresses due to preloading, due to tightening, then in that case, initial load formula, we have to use this one. Initial load or preloading. Next is whenever we are trying to tighten the bolt in the screw and nut assembly, the torsional shear stress will be induced due to the friction. Torsional shear stress due to friction between nut and bolt, nut and screw during tightening. So that is given by T by J is equal to tau by R. So now here T is the torque that has been imposed on the nut. If you consider this assembly, okay, due to these solid surfaces, interaction of solid surfaces, definitely there has to be friction present. And once the nut, on the nut, if we apply the torque or the turning moment, definitely due to the interaction of solid surfaces, the screw portion will be subjected to twisting. So torque is equal to tau by R into J. This is tau into J is pi by 32 dc cube, dc power 4. Why? The reason is dc is the core diameter and that is the weakest part in the bolt, and that from there only the failure is going to initiate. Pi by 32 dc power 4 divided by dc by 2. This comes out to be as tau into pi by 16 dc power 3, or dc could be written as 16t by pi into tau raised to the power of 1 by 3. And once again, we can recall the empirical relationship. DC is equal to 0.84 times of D. Okay. So this is another kind of stress induced in the nut, induced by the nut on the screw during the tightening process. Now moving to next kind of stress that is being induced in the bolt is bending stress. So bending stress will be induced when any one of the surface, or let's take an example. This is the bolt kept in some assembly. This is inserted in one of the components, and another component is having certain inclination, so whenever this is not, when the surface is not normal to the shank of the bolt, then it is going to suffer bending stresses. It will be suffering bending stresses. So bending stresses is given by sigma by y is equal to E by R. This is the relation we will use, bending equation. So here, instead of y, the distance for neutral axis, y will be equal to x by 2. So this becomes as sigma by x by 2 is equal to E by R is nothing but radius of curvature, that is length of the bolt. So sigma B, that is bending strength, is equal to E into X divided by 2 times of L. So whenever the surface is not normal to the shank diameter or to the cross section, then the bolt is going to suffer bending stresses. Next is, during the tightening process, shear stress will be induced across the threads. That means, let's say this is the bolt. So due to the tightening, the chances is that the thread surface is going to slide against the cylinder, and this portion is going to be sheared off after the thread has been slided. This will be sheared off area. So the load will be imposed along the axis of the bolt. So load is equal to shear stress into area. So P is equal to shear stress into area. Area is circumference of the thread, that is pi into dc, that is core diameter. From there only the failure happens. Okay, pi into dc into thickness. This will be lateral surface area that is going to get sheared off into number of threads over which it will be distributed. Okay, so this is for bolt calculation. Average shear stress across the screw thread. Same way, average shear stress induced in the bolt, average shear stress induced in nut is equal to P is equal to tau into area. So for the nut portion, instead of core diameter, nominal diameter would be used. That is pi into d into thickness. Thickness of the thread, T stands for thickness, thread thickness. Okay, this is the dimension T. Pi into d into T into n, number of threads in engagement. Number of threads in engagement. Next is, due to preloading, the threads are also likely to suffer crushing stress. Crushing stress in threads. So if you observe from the top view, especially the thread portion, this is the thread or threaded portion. It will be like a helix, not a straight surface. It will be something like a helical surface. Okay, so whenever we try to clamp this part or this surface area, which is like a hollow circle, okay, will be subjected to crushing. Will be subjected to crushing. So load P is equal to sigma C into crushing area. So that is crushing area. This part is core diameter and this part is nominal diameter. So P is equal to sigma C into pi by 4 into d square minus dc square. Okay, so these are the stresses induced in the bolt during the preloading. Next is stresses due to external load. So once again, due to the external load, the bolt will be suffering tensile stress. That is, P is equal to sigma T into pi by 4 times of dc square. So this formula has been repeated even in the preloading, even in the bolt strength as well. Okay. And same way, shear stress, that is going to be suffered in the shank portion. That is, shear stress is equal to load P into tau into pi by 4 times of d square into n into n. So n stands for number of bolts that are going to support the load. Earlier, n was counted as number of threads in engagement. So these formulas we use especially for power screws. Power screws, example for that is screw jack, or the screw which is used in clamping, that is which is used in bench wise or pipe wise. So these are the examples of power screws. Okay. And n over here is going to tell us number of bolts that is going to resist the load. N stands for number of bolts that is resisting the load. Okay. Next is stresses due to combined load. So what happens is when the two surfaces are clamped together by using the bolt, between the two surfaces there will be one more additional element that is being present. It could be a rubber gasket. It would be a rubber gasket. Okay, or gasket joint. And this is together clamped by using the bolt, nut and bolt assembly. So this is first case. In the second case, gasket would be absent. Okay. So in that case, load or the resultant load will be combination of external load and initial load due to tightening. So external load is taken directly and initial load so adjacent to external load, or sorry, initial load due to tightening, this is generally taken as Pi equal to 2840 times of D. This is the empirical relationship that you are supposed to remember, and D is the nominal diameter. Okay. Next is adjacent to external load, there is a stiffness constant that needs to be multiplied. Let's call it as K. K stands for stiffness constant. So this stiffness constant is expressed as K is equal to KB by KC. That is stiffness of the bolt divided by stiffness of connected members. Okay, this is actually the factor A, and K will be expressed as stiffness constant K can be expressed as K is equal to A by 1 plus A. So this value is generally less than 1, and this is multiplied with external load. So if we are using metal to metal, if no gasket is there, if no gasket is used, then K will be equal to 0, and resultant load, that is PR, is directly equal to PI in case if no gasket is used. Okay. So likewise, there is a tabular column available for factor K, that is metal to metal, it would be 0. Lead gasket with studs, it would be 0.1. Same way, if we are using soft packing with studs, the value of K becomes 1.0. Okay. So these are few empirical relations and formulas that you will be using to solve the problems on design of bolts. Now, the kind of problems you can expect, especially from this topic. So almost every problem involves using of tensile strength equation. Tensile strength equation. Okay. That is one kind of problem. That is P is equal to sigma T into pi by 4 times of dc square. This is for single bolt, or if you are using many number of bolts to support that, then n should be multiplied. N should be multiplied. So this is the formula which is more frequently used in the problems. Other kind of problem from where you can expect a question or definite question is combined loading. Combined loading, that is strength, tensile strength. But tensile strength is equated against P is equal to resultant load, that is equal to initial load P initial plus P external into stiffness factor or stiffness constant. So the value of K is going to be somewhere between 0 to 1 based on the material conditions whatever is being used. So this resultant load, that is resultant load, is equated against the tensile strength. Okay. So there are two types of problems, mainly one of them could involve only using of tensile strength or combined loading. So this is P initial is 2840 times of D plus K into external load. This external load could be given directly, or either it could be given in the form of pressure over a surface pressure exerted on a circular plate. Okay. So in that case, pressure into pi by 4 times of diameter. So that's how a force or pressure can be converted into the force. Okay. So either of these two possibilities has to be reflected over here. And again, this is equated to tensile strength, that is sigma t into pi by 4 times of dc square into n. So these are the two kinds of problems from where you can expect the question. Along with this, also, design of an eye bolt could be expected. But here in the eye bolt, you have to remember the proportions. You have to memorize the proportions. Calculating using formula is easier, but the proportions is going to be a bit challenging. So that you have to remember. Proportions of drawing. Okay. So many times they would ask you to sketch. Even they would ask you to sketch nut and bolt assembly. Once again, this is going to involve the test of your memory. Okay. And the formula is one simple, that is you will be using tensile strength most of the time. Okay. So these are few hints and tips regarding the questions and regarding the concepts. And in the next session, we will be coming up with the questions from the bolts.